I guess we're gonna give it a few more minutes
Yeah.
so everybody can jump in. But are you ready, Corbin? Are you ready to do the bubble bomb webinar?
Yeah, of course.
Is it safe? Is your PC can your PC handle it this time?
Well, I've been having some graphics cards issues, to be honest.
No
Uh,
way.
literally, yeah.
Like what?
But I don't know if it's just drivers or something.
Hmm.
So the screen flickers sometimes, but it's usually just on when I start it up, and if I maybe start Houdini or start OBS or something like that that requires the graphics card, then it does
Hmm.
seem to like the screen will go off and on a few times, and sometimes that means I have to restart because like it won't start. Like I couldn't open Figma because it was like saying, oh, the WebGL is not installed, and I'm like, that's bullshit. Then
Hmm.
after restart it's fine. So yeah, it's a bit dodgy. I'm like, yeah, I might try reverting to previous drivers because obviously since I reinstalled everything, I just got the latest drivers, but previously I hadn't updated. So maybe it's that I've got too late of a version of drivers and it's not compatible or not. I've reinstalled it several times. We'll see. Otherwise, if it is the actual graphics card that needs replaced, then maybe I'll need to do that as well.
I mean, if it works, it works. Usually, if it when it stops working, it dies. It's not just like, oh,
Yeah,
I'm
yeah.
dying. Oh no.
But see, that's what happened with my SSD is it started giving all these warning signs where it was like it still worked, but it took 10 minutes to turn on my machine every day.
Hmm.
And I was like, this doesn't seem right. But I just left it, and then all of a sudden it died. So I'm like, nah, is this the beginnings of the signs that I should get a new graphics card, or is it just something I can fix? I don't know.
Hmm. Is it
Um,
maybe it's just that are you simulating volumes or just
I mean, I am, but this doesn't happen when I'm doing anything except opening up, like starting up my machine. Sometimes it even happens. When like before you even enter your password,
okay, okay. Hmm.
it will sometimes flicker, but usually it's as I'm opening OBS or as I'm opening Houdini,
Hmm.
then it flickers. Um,
Interesting.
so yeah, could could be could be on its way out, or could be something that's fixable. I don't know.
Yeah.
It's someone was asking which graphics card, but yeah, RTX 6. I think it's that. Anyway, I'll
Wait,
hopefully it doesn't die.
how much VRAM do you have? Isn't that like 48 gigs of VRAM?
No, I think it's 20.
24?
Is it 24 or 28? 24. Yeah. I'm surprised that it's 24.
Hmm.
Yes, Quattro. So,
Cool. Yeah, it could be some like my screens are quite old by now,
mm,
and every now and then they flicker, or one of them would just turn off, and I just have to turn it off and turn it on again, and it works. I've
mm.
been thinking about getting new screens because I had these for a while, but it's been doing this for a few years now, so who knows?
Mm. But you see, does it affect anything on the
No, I
like?
think
Because
I,
mine will flicker, but I don't think it's the screens because after it restarts, then
mm,
certain things that relate to the graphics card will not work, like Figma won't load because it needs WebGL. So
yeah,
that's saying it's not just the screen; it's actually the graphics is
yeah, it
dying.
could be
So I
the
think so.
HDMI either cables
I'm
or yeah,
using um,
micro.
not HDMI, but what's the other
Oh, the display
freaking
port, display.
yeah,
I think it's called display
DP.
something.
Yeah, that's it.
Yeah,
Yeah,
display port. Yeah,
yeah, that's what I'm using.
yeah, yeah. I don't know. Could be a
Mhm.
cable. Could be a thing. Who knows?
Hmm.
But hopefully it doesn't die because I think that RTX 6000 is quite expensive. Uh,
Yeah, it was not cheap.
I mean,
It's
honestly, I think
better work.
if you just get the gaming version, which is I think it's the 3090 was the equivalent of RTX 6000. And it's like at half the price, but it has the same amount of VRAM, and in most cases the clock speeds are even higher. Like the Quadros slash, the RTX 6000s are just like the fancy studio versions, but essentially they're very much almost the same. I think
Yeah.
they just have to pass. Like I don't know exactly, but I think they need to pass a few more tests, and then they're like, oh, this is like the studio. This one will work forever kind of version. But yeah, I think 6000 should have 48 gigs, right? I also think that, but who knows?
Not mine. I mean, according to like in my if I check it, yeah, it might be the generation because I don't. It does not. It has 24.
Okay.
Because we were chatting about this in the last webinar, so I went and actually checked, and yeah,
Mm,
it's definitely it's not even 32. So, but I couldn't remember if it was 24, 28. It makes sense that it's 24 though.
sweet.
Yeah.
All
Anyway,
right. Okay, let's get this
should we get started?
let's get this party started. So today we're going to be looking at finally at the overview of the bubble bomb. Before we start, we a few days ago we launched the Hall of Fame. This is the first time we're launching this, and it's essentially that's our version of getting a certificate at DoubleJump. You get two certificates with DoubleJump. One of them is a certificate of completion, which is just, this, oh, you watched all the videos, congrats. But this is the one that actually counts. And if you get this one, which is if you get the certificate, it means you get into the Hall of Fame. So we're going to promote your work. You're going to be on the Hall of Fame. Think of it as the Rock and Roll Hall of Fame. You're one of the legends, the rock and roll legends, in this case, the VFX and CGI legends. So I mean, the first batch of Hall of Famers is insane. Like the quality is so high now, like on the first go, that I have it's gonna be dude, I don't know if I would get in. Like it's so high.
I wouldn't give it to you.
Yeah, I know, right? So it's
I
extremely
know.
high. And then on top of that, there were a few people, in this case, 4 people, who literally went above and beyond. And we decided to give them this is the ultimate tier, which is the golden ticket, double jump golden ticket. So that's like the peak, the ultimate tier. But yeah, if you guys after you complete a workshop, after you complete your workshop project, you can apply for the Hall of Fame. So I think we're gonna have the applications are gonna open 4 times per year for the Hall of Fame, and you can resubmit as many times as you want. So if you get rejected, don't worry, we're gonna give you feedback. You can polish it up, submit again in a few months. So that's how it's gonna work. But yeah, it has to be super difficult. It's exclusive, and that's why it's good. It actually means something. When you get in, you're one of the, like, honestly, it's hard to get in.
Mhm.
So that's my announcement. And now we can go to Corbin, who's gonna talk about the bubble bomb.
So, what I how I kind of want to structure this is I'm gonna show you guys sort of through my scene. I'll sort of take my latest scene and walk through it, tell you some of the cool things we're gonna learn and some of the, especially the most unique and interesting aspects of it that we're gonna tackle. So I'll sort of show you some of the like sneak peeks of some of the bits that is going to be in it. But I think a really nice way to do it is to keep it quite free flowing. So if you guys have questions, just keep them popping up. Maybe even Urban, if you see a really particularly good question, because I'll be trying to explain but also read. So if you see a particularly good one, maybe say it out loud and I'll answer it as we go. So I know vaguely how I'm going to sort of walk you through the scene, but also feel free to jump in with questions and things you guys want to know, or and then we'll just tackle it that way, because I think that will be probably the best. All right.
Sweet.
So let me share my screen. Okay. And yes, I'm on the app, so don't worry. We should be all good.
I was just about to ask, but I was like, nah, there's no way.
Yeah, after my PC died, I didn't bother installing the app again. It's crap.
Yeah, yeah.
All right. Can you see my screen?
Yes.
Good. Brilliant. Okay. So, Bubble Bomb. This was a really fun one. Actually, maybe a little bit more complicated than I gave it credit for at first. I thought this was probably going to be the easiest of the three. But I don't know. I think it's actually quite tricky.
Mm.
I think it's a good example of an effect that is, when I say basic, I don't want to say like basic as in easy, but basic as in not necessarily a lot of custom or magical things, but rather just layers of realistic effects, like lots of dust, lots of RBDs, all of that, just layered up. So you can have a very incredible looking effect, but that is all just sort of based on real simulations, right? Like the, fire and dust and RBDs and everything, rather than like these very custom magical things. So this has a lot of that to it. But along the way, there have been so many little aspects of it that did need to be kind of custom that, yeah, it's kind of turned into a bit of a hybrid. Like, there's quite a bit of custom stuff going on, solvers and weird things inside the solver, like inside the sims, rather than just simply, oh, it's a lot of layers, which there's nothing wrong with an effect that is just a lot of realistic layers. But I always love that kind of custom stuff. So, yeah, this was fun. So I even separated it into three of the sort of dev sections. You guys, if anyone's done the first, the disintegration effects, you'll know that I basically work in these effect setup nodes, and then write out my actual output layers into these element layers. So you can already see how many layers there are here. And in fact, I've got one for dust, but I'm going to actually separate that into all the layers of dust, which I think there's like about 8 or 10 or something like that. So yeah, we've got tons and tons of layers coming out of here and going to USD. So yeah, phase one, which is really, really simple. I'm not going to go heavily into this, but we do actually build the environment, right? So we are doing height fields and stuff to create this environment. It is not an environment workshop, so we don't spend tons of time on this. I think you could get a much more detailed and interesting looking environment than this if you really wanted to do like proper hardcore environment stuff. But then, I'm not the guy to teach that. We should rather get like someone who's an actual environment expert. In fact, Urban, I was thinking we need to get James Hardgart on. But yeah, but we cover the basics of using height fields, but also some really cool tricks for getting like, foreground and background separation. So we actually create a foreground and then the background tucks just under the lip of this foreground, so we never see the seam from inside of our foreground. And it's also fully procedural, caching the foreground and background. So if you just literally make any changes to your setup or even move where your height field is, so maybe you want to move your foreground to a different section here, you simply just hit recache and it recalculates everything, including the separation of your background and foreground and the kind of trying to make them match, but then shifting the background just underneath the lip of the foreground. So all of that is so fully procedural. If you make any change, you need to do nothing but just hit a bunch of recache, and that's it. So really nice setup, but I would not say this is the most complicated thing. We just do a couple of cool little tricks. One of the nice things is we show how to do terracing, but terracing on an angle, because usually it's just flat, like horizontal. But now I'll show you how we can actually rotate our terracing. That was actually one of the other cool things. Yeah.
Sweet.
So that's about it. So really basic environment setup. Mostly just because we don't have a modeled environment. We're able to just create some mountains ourselves. But then the real meat of this is our explosion. So, in fact, I'll sort of just show you from camera what my proxies look like. So these are obviously all just cached out proxies. It's a little too slow to play in real time. In fact, I probably should have play blasted this. But we've got our bubble bomb bursting out. It eats up the ground, which we actually have this in a proper it's not even a sim. We're doing this with Prim Intrinsics, is actually moving all these packed pieces and kind of having it like eat up the ground underneath it. And so the bubble bomb expands into the mountain. Of course, we've got dust layers and stuff being kicked up by that, including the leading edge is all sort of like burning, and then as well releasing a big kind of rolling cloud of dust. And then it collapses. So once it reaches the maximum size, it starts to collapse. Also, even the collapse is all fully procedural, which is really nice. And it creates a field that pulls all of the dust in, like, so it sucks the dust into this kind of vortex. And then we also have the shockwave that bursts. And it was actually a little bit of a happy accident, but I decided to keep this kind of spiked part of the mountain and let the shockwave actually rip through it and have that simulate. It's kind of like that, in the Lord of the Rings, the last Lord of the Rings movie, where the tower is busy collapsing and then the shockwave blasts it
Whoa,
off to the side. I
spoilers.
was like kind of inspired by that.
Spoilers.
Oh no, have you not watched the third one? Okay,
No,
yeah.
of course not. It just came out. Still waiting to watch that.
Okay, yeah. um, And then, of course, we sort of, after that last shockwave, we also begin a bit of an avalanche. So obviously, we've got all the rocks that get destroyed, but we also have the really big pieces start to kind of slide down. But I'm going to show you in the course how to control all of these. Obviously, keep in mind these are my low res proxies that I'm showing here. Um, that this stuff we can control separately to these. So even though they're within the one sim, we can have these be affected by forces that these are not, and have these slide down. And there's lots of control. So that's one of the main things, is showing you, it's basic rigid bodies, but I show you a lot of tricks how to kind of get exactly what you want and how to art direct it without having to go back and resim a million times, hoping you'll get exactly the right results. We can separate areas, have those sim with different settings and so on. So that's pretty cool. But I think the most interesting part of this that I'm really excited to show off is kind of the explosion and the bubble, which I think to me is the most kind of magical part of this. Because even though an explosion is an explosion, right? And obviously we're talking to Mr. Explosion here, so but this, in terms of an explosion, is actually quite simple. There's not a lot of detail because the point is it becomes a sphere. What we're trying to do here is mimic sort of pressure. The same way that really small scale liquids would have there's an attraction force. So all droplets of water are attracted to one another, and then they're so attracted that they form a sphere. But obviously they can't collapse on top of one another. They can't compress. So they're pushing out and in, and those two forces balance one another out into a sphere. So what we're doing here is we're actually building a custom version of that, where we have an inward and an outward force that fight against each other, but we're doing it on a massive, massive scale inside of a volume sim. So I'm not really faking this. This is actually pretty much exactly the approach we went with. So I'll kind of just jump inside of here and show you. But we get our basic sim, which our source is using our new tool set. Although I haven't actually updated to the latest, because this was a little bit old. This is when I was first deving it, so we haven't even renamed it. We were calling it the Ultimate Explosion tool set, but then we
Master Exploder.
we renamed it Master Exploder, exactly.
Yeah.
So yeah, so we use that tool set. So I'm going to show you detailed how to set that up, and we go through all the tools as well. And of course, the tools are included, but yours will be the latest ones, the actual. In fact, even as going through it, because I've been recording these videos this week, I've found a few bugs, and I'm going to fix those before giving you guys the tools, so you won't even need to worry about those bugs. Yeah. But the real interesting part is happening inside of here, and yeah, this was really fun to figure out. So we actually, we have to do it in two separate SOP solvers, because what we need to do is write to two different sets of geometry. One, we're actually writing to the geometry. So what we're doing is we're basically creating a volume, like a SDF, that we're actually needing to store, because we need to actually export it out of the sim at the end, and then we're affecting the velocity. So basically what we're doing in here is we're using our density and basically kind of shrink wrapping it. So we're kind of encompassing, even if there's divots in it, we're just ignoring those and wrapping it. and we're creating a new volume, a new SDF that is essentially a smoothed version of that same shape, but it's not completely spherical. It's taking that shape and kind of making it roughly more spherical, and using that SDF to basically say everything that's outside of that SDF should have an inward force, and everything on the inside should have an outward force. But then we're able to kind of control whether the inside force is stronger than the outside, and maybe there's a threshold where we have no force close to the surface, so close to where the SDF would equal 0, so that we're able to kind of let maybe things flow naturally when they are in the region we want them to be, but when they start escaping that, they get pushed in. Or also the outward force really helps because we do use divergence to try and get the volume to expand, but if our divergence is too high, you lose a lot of detail. It becomes very just like a giant sphere, but almost like with no detail. It looks bad. That was my first attempt. Was, can we just crank the divergence on this and can just get a sphere? And you get a sphere, but it's a really, really ugly sphere. So what we're doing is rather letting it evolve naturally and using outward force to kind of keep pushing this volume out to reach the edge of that sphere. But also if it escapes, we're pushing it back in. And the balance of those is how we create this sphere. So we actually go through a few different methods of how we could do it, but the method with it actually works the best is just simply doing a convex hole and then smoothing that, and then we use that as our volume. But this part is really, really cool. So basically what I wanted was, I want the mountain to be there as a collision object. I don't want to just ignore it and essentially use the sphere to cut out or delete the mountain afterwards. So basically it's like it's so explosive and so hot that it just instantly evaporates the mountain, because that's a bit boring. And even in our reference, you can see that as the bubble is moving across the surface, it sort of bends back a little bit, like it's got some drag along the mountain. So I was like, yeah, that's really nice. I want it to actually interact. So it is in there as a collision object, is our mountain. But what we do is we store basically our bubble. So that same SDF that we're using to create the in and outward force, we're storing that as a collision erode volume. And we add to it every frame. So as it's changing and expanding those areas, it's sort of just additive. And then because collisions get recreated every frame, they get re-imported every frame. So it's going to obviously import our perfect mountain. I then use that volume to subtract from the mountain. So we're cutting into the mountain. And then but we do that just before it actually uses the collision object. So we're able to basically iteratively and progressively erode this mountain. And that's why we use this additive value, because we could use it. We add the volume every single frame, but then we multiply it down by quite a lot. So essentially, for the first few frames, it hits the mountain and just presses against it like it is solid rock, as though it's a solid collider. But the longer it is there, the higher the volume accumulates a value, and that value starts to erode the mountain value. And so it actually pushes the mountain away, but slowly over time. And I'll actually show you guys. You can kind of see it. The best way to see it is to see what the volume does. So this is what our volume looks like. And it's kind of like a brainy shape, which is exactly what the reference looks like. So this was kind of, at the very first few frames, we get that more spiky collision shape, or like explosion shape. In fact, you could even push it in a even more extreme non-spherical shape, because then for the first few frames you get this really interestingly shaped explosion, but it very quickly settles into a sphere. And because of that small amount of divergence, but then that constant inward force, it creates these little knobbles, almost like a brain kind of thing, which this, when pressed up against the inside of the bubble that we're going to create, looks really cool. Like it kind of creates exactly like what is in the reference. But what I wanted to point out is here. So this part, which, okay, it's a little hard to see because it's so bright, but this is where the mountain is, and I can show our mountain, right? So you can see that's where the mountain is. But the mountain at the beginning was certainly not perfectly like that kind of arced shape, right? It had that little outcrop. But you'll see over time, although it certainly expands everywhere else equally and essentially becomes much more spherical outside of the, like far away from the collision object, where it touches the collision object, you can see it's only slowly eroding.
Mm-hmm.
Yeah. So this helps create that sort of, it's like a bubble that's being squeezed, So it's a sort of like balloons out in areas where there's no resistance, and then it squeezes against this thing, but now the surface starts to erode. And then that's one of the reasons why we have to do it in two separate SOP solvers, is because we want to write out that volume. Because now what I do is I create a no, sorry, not from there. From here, we get a collision erode volume that actually comes out of the solver, and we write it out, because then we use that not only to create the bubble, but also to, again, erode the mountain. And I keep the inside of that erosion, I keep that ground, but that's the bit that I then fracture, and then using some prim intrinsics, we actually rotate and move those pieces up. So without a sim, we're able to actually just have that sort of lift up and dissolve into nothing. And then we keep that scooped out, hollowed bit of mountain, that is the mountain that we then fracture and do all our RBDs on. Okay, so that's kind of like the concept here of what we're doing. And again, like I say, this shape we're also using as the basis for our bubble. But because the geometry is changing all the time, because of course it is just a converted SDF, we also fix that. We don't really want this. We want the shape, but we actually go and use a sphere, and we reproject that sphere back on, so that we are able to keep consistent topology. Yep, which really helps us. Something else we do as well, which is really nice, is we transfer back the values at that edge. So where the explosion is pressing up against the bubble, the hottest areas, so we transfer temperature, the hottest areas cause more churn and bubbling in the surface displacement. But I wanted that to be, because it's moving and changing so quickly, I wanted it to kind of hold a temperature value and slowly change to whatever the new values are. So we, in the SOP solver, are sort of progressively taking new values, but blending it with the existing value. So you'll see here, if I visualize our temperature on this bubble, you can see those values sort of slowly gets hot in that area, and then it spreads out. And that really helped me creating a natural feeling of, if we use that temperature to drive the bubbling, that the bubbling bubbles up and then slowly dissipates, rather than it's suddenly bubbling and in a frame later, boom, it disappears because the shape of the explosion changed. So then the temperature is live, and therefore it suddenly disappears and has no bubbling. That looked weird. Because I will mention, we're not doing a flip sim for this bubble. It just makes absolutely no sense to try and control the flip sim to then have such a huge, thin, and also the problem with flip would be, if you give it any velocity and it's churning around, it's going to separate, so you're going to have gaps. So now you've got a bubble, but it has holes in it. Like, it's just impossible. So it was much, much easier to do it procedurally. So once we've got our sphere, we're even doing some bending. So at a certain point, we actually have it. I'll sort of show you here. We're actually squeezing the shape, so it looks a little bit more like that. When a bubble gets too big, it starts to actually deform and almost wants to separate into two bubbles, or collapses in the middle. So we are sort of faking that a little bit there, and then doing the collapsing as well, all fully procedurally. So it's so easy to control. And then turning that into a bunch of forces as well. We then trim our volume based on that exact, the volume sorry, the bubble, so that, of course, it mostly is following that shape anyway because of the forces, but occasionally you get some volume peeking out, and we don't want that, so we just trim it afterwards to be perfectly inside of that that bubble. Okay. Yep. So that's pretty much the explosion, and then the base of the bubble.
Sweet.
But then the bubble, the best way to make sure that we cover the whole surface and never end up with any gaps was that we would essentially be scattering points on it, and the movement of those ripples and waves and things on the liquidy surface are all essentially just displacement that's moving up and down along the Y. It's basically a mountain. But so it looks like a ripple moves, but really it's a ripple of energy. The points themselves are not moving, so you never get any gaps. So this part's a little bit heavier, so it might take a second to cook, because of course we're scattering, loads of points. I think it's like 10 million points here, which is not usually that much, but of course it does take a second to cook. And then there's our surface detail. Now this node, there's a ton going on in here. Yes, it's a bunch of noises, right? So exactly as you'd expect, it's a lot of noise. But there's a lot of we're going to cover this in great detail of how to layer up noises, where we're actually using, to create these ripples, we're using a turbulent noise to drive curl noise. And that's how we get these kind of ripples where we're able to actually animate or mask out certain areas. So in your hotter areas and colder areas, you've got more turbulence, but it all goes through the same curl noise. Okay, so, and that's how we get this kind of detail, which obviously here I'm trying to sort of just visualize it. So you can sort of see we get those kinds of swirls and liquidy shapes, but really the best way to see it is actually if we look at the final geo. And especially in motion, this looks really nice. Mm-hmm. So we've got like waves moving across the surface, but we also end up with literally ripples going out and things bubbling up and then disappearing based on a couple of things, based on temperature, based on some moving noise as well, but then also based on the overall size. So as it, in the beginning, it's very noisy, and then it settles because it's almost like that amount of liquid is stretching out, and also the bubble itself slows down and the temperature values cool right before it then collapses. So we kind of get this very liquidy movement, and then it almost stretches and simplifies and then collapses. We will be adding a layer on top of this, which is essentially white water. So it's like getting your splash spray stuff from waves, so that especially when the bubble slows down, it feels like there's some follow through. There is some material that is kind of continuing forward and splashing and falling down with gravity, but it's just a thin layer on the surface that is this spray, which helps it feel more like it is actually a flip sim or like it's liquid, as well as obviously this liquidy noise. Mm-hmm. So yeah, we get lots of detail from this, but it also moves really nicely over time, which is one of the most important things. Okay, so it's a combination of noises and also some sine and cos waves type of thing to get those like ripples and things. Mm-hmm. So it's funny that this is like such a small setup, as in only a couple of nodes, but this is probably, I mean, half of the work is probably going on just inside of this one FOP, right? Yep. So shockwaves. Shockwaves are sort of like harder than you actually tend to think of them, because it's like it's just such a quick sort of just like this burst, right? But to get it to actually look right, and like it's a you want that sort of volumetric shape, but also if it moves in 3 dimensions. So if it's just a volumetric sphere, then it's, unless you're inside of it, you really can't feel which direction it's coming from. So anyway, we solve all of that by doing, I'll show you now, basically a Fresnel, as well as we use the distance to the collision object to kind of override the Fresnel value as well, because essentially as the shockwave moves, I want to see it moving across the ground, and I want to see essentially a ring but I don't want to actually create a ring. I want it to be spherical. So I wanted to essentially use Fresnel as a way to say when we're looking directly at the sphere, we're looking straight through it and we barely see any volume. But around the rim, it gets progressively denser, as well as along the ground, it also gets, so the distance to the collision surface, it also gets denser. So if I visualize my density and show the shock wave. So these are these points, and this value that this attribute that I'm visualizing here is my density of the volume, right? So as this is moving out, you're going to see these are going to be trailed, and these will be the densest part of the volume. But you'll see at the top here, it's not very dense, and that's because we're looking from this camera. So as the shock wave goes out, we get to see essentially what is a ring, but it has a bit of curvature to it. Likewise, we switch over later on in the timeline. You'll see now our Fresnel is different because on this, we're actually looking through our third shot, our third camera. And so there, boom, we then get to see this expanding sphere, but because of the Fresnel, we actually see it so much better. Okay. So then you get, obviously keep in mind, volumes don't visualize that great in the viewport, especially simple ones, but basically this is what we get, except of course you then have control over how long you want those dense areas to trail behind. So you can get those, you know, some of those shockwaves are very spiky.
Mm-hmm.
You can get that look really easily, or you can get that kind of ring or spherical look. So this one setup can actually solve most of your shockwave needs. I mean, you can see there in the beginning, it's very trailed, and then I shorten the trails over time. But you could keep them long trails if you really wanted to.
Should we make a shockwave tool? shockwave
I will.
toolset. Yeah.
Everything I do, I want to turn into a tool. It just takes time.
Right. Yeah.
Yeah. So, yep, that is I would say those are the three main effects. However, of course, there's a huge amount of work spent as well on the rigid bodies and the dust.
Mm-hmm.
Particularly, I want to talk about this rigid bodies setup. But actually, before I even talk about that, I'm just going to show you in here. So you can see here all of these different layers of dust that we're writing out. And then the destruction sim, there's loads going on here because these are all subnets that each include all different parts. So we're calculating different rigid bodies, debris layers, all sorts, right, from this. But we've set it up so that it uses, I basically calculate all of our forces. So based on our two shock waves, I calculate the forces. And then based on the suction and the movement of the bubble, I'm creating all these forces. And once we create them, every single sim uses those same forces. So now I can update my shockwave and then hit resim, and it just all goes, and it's really, really nice. But we've done it in a way that we can control per sim how much it's affected and whether it's additive or pull or whatever. But yeah, it just sort of uses all the same forces and all the same collision objects as well. So a really nice, neat setup. So we calculate everything before, and then we just sim. Now, the biggest thing with the rigid bodies that we are going to cover is the freaking RBD material fracture is the worst node ever created. It is garbage.
Well,
it does not work.
They fixed it a bit in the 20.5. I think they redid the, well, at least some parts.
Wait, 20.5? Oh, yeah, okay. So I'm not in 20.5 yet. So hopefully, maybe there it's better. Because, just no, right? It's terrible. I've literally had it where I try to create a sphere to just test it. And, you know, it looks like it works, and then you change the seed, and then it doesn't work. And the problem with that is because you want to do it, you want iterative fracturing. So you want to fracture, and then you take those small pieces and fracture those, and then those small pieces and fracture those. And because it's then iterative, within that loop, if any single loop fails, what it does is it leaves the cutting geometry in. So it merges the cutting geometry with the geometry itself. And now you have to go back and try and figure out which piece that happened to. And the worst, because I had this when I was working on one piece and we were fracturing a building.
Mm-hmm.
And so it was every brick, we were looping through all the bricks in this building and fracturing them. It looks fine because at a glance, you're like, oh no, I don't see any cutting geometry. It seems fine. And then you start simming and you've got things exploding until you realize that a piece that this size has a little bit of cutting geometry left in it, and then the whole thing seems to explode. It's
Mm-hmm.
horrible. So
Yep.
we try to work our way around it. I'm going to show you a couple of things like, you know, it's not so much just a fancy way to fix it in Vex or whatever. It's more just a methodology of how to work with it where we can sort of break it down into smaller chunks so that we're able to attempt to fracture. And if that fails, of course, it's only fractured in that one region, and so we can reattempt it or whatever. But I also do build my own version of the iterative fracture. So, but what it attempts to do inside of this loop is it tries to make sure that the fracture, like the cutting geometry, is much larger than the original piece, and then it uses after the loop, it looks at the overall bounding box of the piece that has been returned,
Mm-hmm.
and if that it is similar in bounding box size to the cutting geometry, then it sort of assumes that hey, this failed, and instead of letting it fail, it keeps the original piece and says, well, I failed to fracture this, so I'd rather give you back the thing that was working than give you back some thing with a,
Yeah. Half
you know,
fractured. Yeah. Artifact.
how I picture it. It's like a lumberjack, getting a axe stuck in the tree,
Mm-hmm.
like it's that is exactly what
Yeah.
so
Yeah. I
so
get
what
it.
it does is it basically it fails to fracture that piece, but I'd rather it fail and give me a piece that's just fine, because then that you actually get natural variation as well. You get some pieces that are still large and unfractured because it failed, but then a couple of the others do fracture and it works. um so yeah, we're going to kind of try and cover that. I will admit, even my version of the iterative fracture does sometimes fail. And I still haven't figured out why, because it's got a very clear if statement to say if this has failed. It also even does other things. It creates vertex attributes on the cutting geometry that if the cutting geometry is left in, it detects that attribute value and says, hey, you've got a corrupt value. You shouldn't have a value of 1. You should have all zeros. Therefore, you must also have. So I'm doing multiple checks to try and get it, and yet it still does occasionally fail. But my tool's success rate is probably like 80%. The freaking material fracture success rate's about 10%. I
Mm-hmm.
hate it.
Yep.
So it's not perfect, but I'm going to show you how to work around it. Hopefully, this becomes redundant when if they actually fixed it.
Mm.
Um, but we'll do our best. Okay, so that's something I show, and then also some really cool just tricks about how to fracture. Because the one cool thing with the material fracture node is that it rebuilds your constraints when it does the iterative looping, right? But that's actually unnecessary. You don't need to rebuild your constraints on every loop. What we do is we simply, when I'm doing the iterative fractures, as long as we name each of those fractures correctly, we can infer based on the name how deep it is in terms of like levels of fracture. And then we just, at the end, I create a tier attribute. So basically, I loop through all the primitives and figure out how deep into that fracture it is, and what its hierarchy is, like what its descendant is. Okay, almost like you can imagine it like literally, I don't know, my family name. It's like tracing my family
Mm-hmm.
tree up to its root, and also knowing that I'm maybe the 10th generation or the 20th generation. Then at least based on that number, what we can do is separate it into like our biggest pieces, our smaller pieces, our small, and so on. And we use that tier number to then decide that, for example, we can multiply constraint strength. So our biggest pieces will break apart from each other easier than the smaller pieces. So rather than having to constantly rebuild the constraints, we just build the constraints once at the end, but using the names of the pieces, we can infer how deep they are in the hierarchy and then base everything on that. So it's such a simple setup. I don't even know why they are bothering to recreate constraints anyway. So I'm going to show you quite a few tricks to do with rigid bodies. Like I say, we did a really, really big, complicated setup on one piece. So this is actually everything I learned on that project is basically inside of this one node here. So I'll share all of that with you. Our erosion, like I say, is actually happening with no simulation. It's actually just all prim intrinsic. So we're translating and rotating pieces using matrices and prim intrinsic attributes, which is a nice, it's quite simple, but it's a nice way to do it if you're doing anything like ground getting hit and you have those like very anime style where the ground like lifts up and it sort of cracks in the middle. Never do that in a sim.
Never.
So easy to do it with just rotations and stuff.
Yep.
I even like earthquakes and you know cracks spreading, all of it just easy to do it this way. So we'll show you how to do that. It's fairly basic though. And yep, that's pretty standard. Then our rigid bodies also is pretty simple. The one trick though in here that's really nice to know, so I'll show you in here this loop. But what I'm basically doing is to create the dust in the cracks, because the stuff is all, you know, all these pieces of the mountain are like right on top of one another. You know, they're meant to look like they're joined, and then you want them that as they break apart, they release dust. But as they break apart, they're not even actually necessarily separating. They might be sliding. So there's not enough space for the volume to actually do anything. So in here, I create a version of every rigid body where I've shrunk down the collision. So there's actually, even though the pieces are on top of one another, in terms of the dust sim later on, they believe there's a small gap where the volume can live. And sure, it does mean that your volume is slightly penetrating the collider before it then hits the sort of shrunk down version of the collider. But you barely notice that in motion. And then what's much nicer is that as those pieces are moving, they're trailing there's like dust in the cracks between them. So that's kind of like a nice technique. Also, we prepare properly for USD. That was one of the things we learned on the One Piece project as well, was because that was actually the first project I used USD on, and it was how do we get USD cached properly and efficiently, where I don't have to store all of this. Like, you know, with rigid bodies, you want to store just the points, and then you want to transform a non-time dependent version of the high-res geometry. And how do we set that up in USD? And so that is what we had some proprietary tools and things to do that at Goodbye Kansas when I did that, but actually, you know, they're not necessary. So here I'll show you how to kind of recreate some of those things. Okay. So that's actually there is the creating the collisions for the dust. And then dust, it's mostly just a whole lot of dust, like just managing forces and sources. Particularly the sourcing is really, really important. So like creating the shockwave. When the shockwave blasts, how do you create that nice, you know, off of any kind of edges, you create that streaky kind of source, which then, you know, so in the shockwave blasts, you get those like thin streaks that come out of anything that's like a rock sticking out or whatever. So we create that, but it's fully procedural the way we create the shape, and then obviously feed that into a dust sim. Crack dust, similarly, it's released from the cracks, but it's also based on how far the geometry has moved. But we also even put that through a solver. So each piece has a certain amount of dust that it's allowed to sort of emit based on speed. So over time, it gets less and less density. Ground erosion, that's quite a simple one. The leading edge is quite simple. And then the big dust burst, which is where we use our MX tools. I'll actually update this to the MX tools. This is the one that Urban was helping us. develop and make look super cool, because that's one of the most iconic parts, is at the end with that last shockwave, and then it, of course, there's lots of little bits of dust, but the main thing is that big plume that just comes spraying out. Big smoke. So there we are. And then the avalanche, which is sort of based on, it'll be based on the same thing, but just with less force and more, it's coming from those big falling pieces. Because if you look at the reference, and I'm actually going to show you the reference here, at the end, there's actually very little in terms of rigid bodies. Yeah, you get a couple of these pieces emitted, but I mean, that's so far away. That's like, I mean, those could be just spheres or cubes. Like, you actually cannot see the details of those. It just emitted a few RBDs. The main thing that gives us a sense of the avalanche and falling is really the dust, you know. And even these big pieces, you watch them moving, you know, they break apart, but I mean, they're not breaking into incredibly detailed pieces yet. I mean, maybe if we saw this for much longer, we'd have to start seeing more detailed fractures. But I think actually the rigid body side of this sim that they did at ILM is actually probably quite simple.
Yeah.
It's the dust that's doing all of the heavy lifting. So we spend a lot of time focusing on the dust on this shot. The rigid bodies is actually relatively simple and is essentially just the big shape that you feel inside of what this big moving cloud.
Yeah.
Okay. Yeah. So, and then of course this little collapse at the end. I mean, of course we handle the collapse. So to get these streaky shapes, as that collapses, you see all the dust gets pulled in and then burst out as well with the second shockwave. That we handle all directly with our forces. But that burst at the end, like of light, that blast of light, is going to be just a light. You know, it's an animated, you know, light inside of there. So and a bit of comp work. So that's, you know, quite easy to recreate. It's more about how it gets sucked in.
Mm-hmm.
And for that, I mean, we'll go into it in much more detail in the workshop. But let me see which is probably the best one to show. Probably inside of here. We do a whole bunch of work on sort of shaping and controlling the volume. But one of the biggest things that we do here is I'm going to show you how to create or how to control forces coming in. So to control your volume sims with external forces, but in a way that gives you much more control than just volume sourcing them in. So volume source, for example, has a pull, and pull is amazing. Pull is actually one of the best ways of combining, because you can separate acceleration, deceleration, and direction if you want to, or you could have direction merged with those two, right? So that's all great. But it's still missing a few things, because there's a big problem if you have a force that has 0 in it, then and you don't want it to pick up those 0 areas and have your volume stop moving when it enters that area, then you have to have your deceleration set to nothing. But what if you do want it to slow down and match the speed? So, for example, that suction is not just additive, it is controlling the movement of that volume so much that we have to use acceleration and deceleration, because anything that's moving faster than it should slow it down. So what we want to do is say, I want you to accelerate or decelerate to match this field, but I want to set a threshold where below this speed, it then counts as being kind of essentially masked out. So this is dead space, and I don't want you to decelerate down to 0. I just want you to decelerate to match the speed of the main force. Mm-hmm. And of course, we could get complicated, load in an extra volume as a mask. What a waste of you know, calculation and RAM.
Yeah.
So instead, we do it all in our own custom weighted average, which I'm going to talk to you about the maths going on in here. I mean, it's relatively simple, but knowing this formula has saved me so many times, because you can do crazy things. Like, you can actually mix 3 different forces rather than just 2 using weighted averages. And you can weight it based on many things. So you can weight it based on distance, or you can weight it based on speed, or you could weight it based on both of those, or, you know, a speed only when it's above a certain threshold, but otherwise distance. Or there's so many custom things you can do with it that I know it seems complicated to do this line of code where you could just set something to pull, but actually the level of control that this gives you is insane. So I would say this is probably my number one trick for getting magical volumes is custom pull forces. So knowing how to create weighted averages. It's it's literally just my number one trick for volumes. So I'm going to show you how to do it. I'll show you the basic. This is the most basic version of it, but you can do anything you want with it. Yeah. So
Sweet.
I think that about covers it for like the kind of the trickiest and most interesting parts of this setup.
Yeah, it's a lot of setups.
So
Yeah.
yeah, it's a lot.
Yeah.
Yeah.
And then we have to, like Corbin mentioned. So this is all this. These are all the FX setups, and this is what you would do in the studio. You would do all the setups as an FX artist, and then somebody else usually takes over and does all the rendering. So that's how we're gonna do it here as well. Like the rendering part will come as a separate part, and we have another person essentially doing all of that. So it's like a handover from one artist, like one department to another.
And of course, the effects artist is still responsible for handing over properly. So they might have to create basic shaders. They might have to, even like in my case here, I'm creating these separate elements. I'm thinking about how it's going to be rendered and separating it into those elements preemptively, rather than just giving a bunch of junk caches to the lighting artist and expecting them to do all the work. I am separating and naming carefully. I'm giving them the attributes that they need, but not the attributes that they don't need. So I'm cleaning up. And I'm also preparing for USD, as well as assembling in USD, assembling all my effects. So I'm creating an effects layer, like a USD layer that's got all my effects in it. Even if they don't use that in that exact way, they might want to rebuild it with their own reference nodes and then rebuild the effects layer. That's fine. But at least what I'm giving them is a sort of a template for what I believe the effect should look like. So we cover in this section everything all the way up to kind of prepping for USD. Then when part 2 comes, so the module 2 for this, I'll still probably teach it, although I might even get the artist on like a call and we can actually discuss a few of the ideas of what went into it. But what he does is he gives me his scene once he's finished with it, and we clean it up and discuss everything that went into it and the decisions that were made, and then I teach you guys everything that was decided of how to get it from effects all the way through then light, render, comp. So and that'll be for every effect. So disintegration, that module is actually coming hopefully soon. Bubble bomb, of course, once I'm finished, I'll then hand over to him, and then it takes a while for that to happen. But so you guys will basically be getting the effects version of this, and then also the kind of like lighting render comp version.
Yeah. We do. I mean, we don't have to show anything, but we do have a few renders from the disintegration module. I don't know if you want to show any of that as a sneak peek here. We don't have to. I'm just saying we have something.
Yeah, I mean they're in my Discord, but I don't know if I've I mean obviously on my PC recently as I've been sorting files out. Do you have something saved where you can show it?
Yeah, I have it saved. If you want, I can show it, but we can also leave it as a surprise. But I mean, for the people who are still with us, we can, I guess, it's a quick sneak peek. It's just only one shot. Like it's gonna be.
Yeah, it's just the one shot, and it's a couple of. I don't even think it's the whole shot. But
No. It's
yeah,
just,
show it's the.
it's just the. Yeah, I'll just send it here.
It's a teaser trailer.
Yeah, it's just so you guys can see where we're heading, but it looks pretty cool.
I think this was rendered on 10s or 5s.
Yeah, it's just tens, I think.
Yeah.
No, it's Karma, right? It's all with USD Karma.
Yep.
Solaris.
Yep. It's Karma, Solaris, the whole thing. Yep.
Yeah, it looks pretty cool. It's gonna be even better. But just so you guys know, we're working on it.
CPU. It's Karma CPU. I don't think we're using XPU for this.
Yeah, and I know it's a bit slow to render as well, just because of the amount of particles. But yeah, I think it's getting
the motion blur on so many particles is definitely slow, but it is a known issue. Like it is, we've spoken to a couple of studios that we know that we were like, hey, are we doing something wrong here? Is this like, because it seems to our render times seem to go crazy, like way up when we turn on motion blur for this number of particles. But they've literally had the same thing. It's like, no, it's just costly to do many points that have motion blur. Obviously it calculates on primitive geometry much better because it's interpolating across the parametric, coordinates. Whereas on points, each point has to be calculated individually. So it is just massively heavy.
So I think this is going to be the level. If you want to get the golden ticket, you need to reach this level of quality with your vendors.
I'm sure the guys in the course are doing even better stuff than we'll do. I look forward to seeing it.
Yeah, you get the golden ticket if you do it better than what we do. If your result is better than what we can actually achieve, then you get the golden ticket.
Nice.
That's the level.
The golden ticket is like A+. You can pass. You can get your certificate of like you can be in the Hall of Fame. But there's Hall of Fame, and then there's the elite. There's the A+ students. Guys that get distinction.
Yeah, I mean, a few of them that we have from the automotive workshop. I was just like, what?
So good.
What? How do you guys do this? Like, it was so good. It feels like a proper like client work. Like and it was done by, well, one of them was like a studio. I don't know how many people are in that studio, but the other ones were just like but done by a single person.
Yeah,
insane.
No, it's
crazy
so
stuff.
mad. When you send me some of those, I would look to it. I was like, what is this?
Who did this?
I mean, who did this? Like, what? Which giant studio did this? It was awesome. So it was really cool to see. I'm like so inspired by the work that you guys do. So we like to share our tips and tricks and techniques and experience that we've had over time. But we know that you guys are pouring a lot of passion into it as well, and we love seeing the work that you come up with. And I hope you'll do awesome things with the film effects. Bubble Bomb should be a lot of fun. And then we'll move on to probably my favorite effect ever.
The Obscurus.
Obscurus.
Yeah, that's going to be awesome. And I think that's going to have even a lot of magic, but also like it had a lot of cool RBD stuff. So I think you're like
more detailed. There's a big because it destroys a building and stuff. So we'll talk a lot. In fact, a lot of some of the techniques we learn here of how to manage RBDs and all of that stuff will carry over. But then obviously the magic is, and the thing with the magic, I mean, there's a lot of ways to do it, and there's a lot of ways to do it quite almost easily and randomly. So you could have like a liquid sim and just push it around with some forces, and you might get lucky and get the right results. But just like how we were talking about this last week about how the Master Exploder tools, it's setting up your source, doing all the work in the source so that your sim, you're not relying on randomness to get the good result. That's how we're going to handle the Obscurus as well. I'm going to teach you guys how to do, like, the main thing to take away from that dev is going to be that we can transition seamlessly and with total control between, because the Obscurus, sometimes it looks like a volume, sometimes it looks like grainy sand, sometimes it looks like a liquid. It just seems to keep warping and shifting between these different materials, and that's based on how it moves, but also how how it looks. And we're going to build it so that we can blend and control the way that it morphs into these different materials with total control. There's not going to be basically any randomness. It'll be the most art directable magical effect you've ever done. That is kind of like the main reason I wanted to dev this was, I don't want to just sim some flip and sim some volume and then try and kind of like blend between them in comp and just kind of make it look like it turned. We're going to actually do it in sim, just morphing from one behavior to another. So yeah,
Sweet.
I'll show you guys how to do that. Yeah,
Yeah, I'm looking forward to that one.
that
Especially
one's going to be really, really, really fun.
yeah. And then
Yeah.
the Ultimate Explosion workshop is, I think we're going to do the pre-sale in 2 weeks, 3 weeks. We're still busy working on all the examples, like all the project examples that we're going to be looking at in the workshop. And I'm busy doing like previews and cool demos and stuff like that. So pre-sale in, yeah, I think 2 to 3 weeks we can do the pre-sale, and then it's gonna take me, it takes time to record. That's usually for me. I know Corbin is almost like the opposite. Corbin records like 22 hours in a week. It takes me a bit longer to record, uh, but then it's just pretty much just recording. But yeah, pre-sale very soon.
Yep. Also, to answer the question of when Bubble Bomb is coming, very, very soon. I'm aiming for this week, like to finish recording. I'm already midway through recording anyway. But of course, we never know. Some things might take a little longer, or we hit a little bit of a snag. So I don't want to promise that it'll be done this week, but that is the goal. Like, and last time when I did Disintegration, I did record it in. It was like about 7 days, I think, or 8 days or something to do the recording. So it's like it might take me maybe like, let's say, 8 days, which I started fully recording on Monday because I lost some files with my PC dying. Although luckily I'd only done like 6 recordings or something when it died. So yeah, I restarted, but I did that on Monday. So it'll be, let's say maybe 8 days, but give 10 days or something to give some padding. But I'm churning it out. Like literally after this call, I'm gonna basically have some dinner and then hit record. So it's coming super soon. And then after that, what we're gonna try and do is do module 2 of Disintegration. So we'll take the render and then clean up the scene and then do the recordings of that. So before you guys are even done doing Bubble Bomb, you should have that to work on.
Yep.
So plenty stuff coming.
A lot. Yep.
The issue with my PC was SSD died, so that was, it wasn't too bad because there was only a little bit of data on that SSD. Mostly all my data was on the other drive, and it also gets backed up, so that's fine.
Yeah.
Although now I've restructured my whole hard drive and where I store things so that I'm always backing it all up. And in fact, I think my HIP files are back up to two different clouds. So
is that automatic?
Just in case one.
Is that automatic?
Yeah.
How did you set it up? Is it? Yeah. How did you set it up?
One's just with Google Drive, just pointing to a folder and saying back this folder up, but it's just the ones that has HIP files. Because those are very small, so that you just back them up all the time just in case. So that's the worst case. You could recreate your whole thing from that. But then the other thing I back up is with Mega. But with Mega, I've selected all the folders that I want to back up. But some of them I back up every day. Some of them I back up once a week or once a month for like the big heavy caches. And then some of them I sync. So my USD folder I sync so that I'm not only uploading what I've done, but I download what someone else has done. So when we're working with the lighting artist, then their changes can come synced down to me all the time.
Yeah.
So yeah, it's set up like that. In fact, sometime I think when I finish the new scene controls tool, I'll also explain my folder structure. Not that you guys should follow exactly the same, but just some of that logic might be useful. So I'll sort of include that in that workshop, that tutorial to say, hey, here's how you can use it to build a pipeline that's quite works quite well with like automatic backups and syncing.
Mm-hmm. Yeah. I still need to start using the DoubleJump scene manager that you've made.
Yeah, the scene controls. Well, I'll do the new version, then you can start using it because the new version is going to be more flexible. So I will finish that one, then I'll hand that over not only to you but also to everyone who's using scene controls. Because when I first gave it over, I think a lot of people enjoyed using it, but there were a lot of like questions or could it have this feature and that feature? So and they were all very valid. It was only originally designed to be used by me. So once I started getting like all this feedback, it's like, oh, that's a cool feature. Yeah, I'd love to add that. So I am working on it whenever I'm not recording. Cool.
So I think of
Oh, I'm also got a new tool coming,
yeah.
which is for all of you guys, just a little teaser as well of a new tool that's really, really useful. We sort of touch on it as a setup in disintegration, but it's going to be packaged into a proper tool. What it basically does is you can give it a condition. So you can say to look for like point count or voxel count, or voxel count with a density value above a certain amount, or with a speed above a certain amount if it's a vector field or whatever. You can give it any kind of condition, and it's returning true or false, but it's returning true and false in a way that doesn't constantly check once it switches. So it's basically like a trip switch. So it checks until it hits true, and once it hits true, it switches and it stops reassessing the income, like the incoming geometry. The real benefit of that is that what you can do is you can use it. Like if you do an explosion, you don't know how many frames you need to cache. You just have to kind of guess how many frames until it kind of runs out. Especially if you've got lots of small explosions in the scene, and you can end up caching a lot of scenes. A lot of frames that are unnecessary. This, once it finds that there's no more voxel data left, it switches and doesn't keep reassessing, which means it doesn't have to recook the sim to figure out that there's no more voxels. So the second it hits that, it caches all the remaining frames. Like even if you set it to 10,000 frames, it'll cache it in basically a second. So what it essentially does, if you had to really boil it down, it basically lets you set an end frame, an automatic end frame to your caching. And you can also use it to set a start frame. So then without having to figure out when you start, if you change your source, it'll recalculate the start frame and start simming from that frame, and then only cache as many frames as it needs to until there's no more voxels below whatever threshold you set, and then it caches 1 kilobyte files. So yeah, it's really useful.
Yeah. Owen was saying that in 2 to 3 years we're gonna have DoubleJump. Well, we're gonna need DoubleJump tools to do VFX. It would be fun, like if we just redo the tools, like,
Yeah,
but
yeah,
just
exactly.
like, yeah, all the tools you have inside with Houdini are great, but we just make more convenient, better versions over the years.
Yeah,
Would be
of
fun.
course.
Yeah.
Yeah, we absolutely should. But this is what it was like at ILP. Like ILP had the best pipeline because it was exactly that. It wasn't like big tools. It was more just like annoying nodes that Houdini doesn't do well. They just had a version that was just better, or just did it like it was awesome.
Yeah.
And actually, the best tool they had, it was just the coolest tool to use. I don't know why. It was actually kind of silly, but what it would do is you run this tool where you could do a selection, or you could just say your whole scene, and it basically goes through and tries to name your nodes based on what they're doing.
No way.
So it'd look through your Vex code, and if you were writing out density, then it would try to give it a name like setting density or overriding density if there was already a density before it was writing it, or and it was actually really good. It was spooky how good it was at figuring out what to name the nodes. So you could just call it wrangle 1, wrangle 2, wrangle 3, and then you hit a button and then you just go, yeah, it's set density multiplied temperature,
Dude, I would need that. I never name anything, and it's the worst because then I open up my scene.
That's the problem.
Yeah,
Yeah.
like 2 days later, I open it up and I'm like, what was I doing here? Yeah.
Like, what is that node, and you have to
Oh
click
yeah.
on it then and read the code to figure
Yeah.
out what it's doing again. But the problem with that tool is now you get reliant on it. So now you don't name anything because you know you can just click a button, and then you leave ILP, and now you go looking for that button, and you're like, no, I have to name my nodes manually again.
Oh no. Yeah, that would be fun
I
to
don't know
do.
how they did it.
Yeah.
Actually, we should link it with AI. Let AI name our nodes.
Yeah, and then have a
Feed
version
it the
where
code and let it come back with a name.
but we need a version where it names everything the wrong way. So it just randomly names
Yeah.
things.
Yeah, wrong answers only.
Yeah, cooking pizza, and it's just like
Yeah.
makes no sense. It's like random things. Yeah.
Hey, listen, with AI, you don't have to make a version where it gives you wrong answers only. You just feed it. That's what it does. Is it only gives you wrong answers anyway.
Yeah. No, that's actually true. Yeah. All right. I think that's it for this one. Yeah, a lot of things coming. Oh, a lot of workshops in the pipeline as well, and the filmmaking in Unreal Engine is also going to start very soon. So I was just chatting with Calvin today. He said he almost recorded everything. He just needs to edit the videos now, so it's going to launch pretty much on time. So that's going to be awesome as well. And yeah, we're going to keep you updated as we go. I think we're going to start doing like a weekly update video on YouTube as well. Just like also with our news from DoubleJump, but just like general news, you know, what is happening in the CGI, VFX, gaming industry. So it's going to be like once per week, essentially news, industry news. I just need to find the time because doing workshops and running everything is just, it's a lot, but that's coming. And yeah, just all good stuff on the way.
Yep, loads and loads of good stuff. Loads of workshops still being worked on. We've got loads of ideas. I've got a million workshop ideas that I want to keep doing. So loads of content coming, guys. I hope you enjoy it. And yeah.
Sweet. See you next time.
See you guys. Bye.
Bye.